This next demonstration comes at a time in the curriculum when I'm trying to get the students to make observations, to make hypotheses. That time when we're trying to develop theories and observational skills, maybe the first time before we even go to the lab. What I have is a piece of tubing, and I'll let you examine that tubing, and a silver flask. That's a Florence flask. They may not have used Florence flasks in the lab before, but they examine that, and then I take the flask and the tubing. You notice the tubing is rather flexible. I put the tubing inside the flask like this. And then there's something that magically happens. Now, I might go through something about the coefficient of friction, about how this tubing might stick to the silver, something like that. Okay, and I want you to, it is so strong that it even does that. Look at that, how it stays right on there like that. Now I want you to again examine these, make sure I haven't done something unusual to them. And as they examine them, they don't know everything. And so they are examining those objects. You've examined them carefully, I see, yes? And you're tearing that one up. We don't want to do that. All right. And so then I have the flask again, and I have the tubing. And once again, we can take the tubing and the flask, put them together like this, and it stays. Now, perhaps you'd like to try that yourself. Okay, there's the tubing and the flask. Now, you can try that. Now, remember, they don't know everything. Ooh, now comes the test. You don't trust it, I see. Doesn't quite work. And so doesn't quite work, right? And so we get the students to mess around with that. We pass it around and let all the students examine it. And then once again, I get it back and show them again that there's really nothing magical about it. You just simply put them together and they stay. It's quite simple, much like stoichiometry. Very simple. But I use this also with the students in trying to make observations. Have you observed everything? Although I gave you this, I held the flask like this. So when I tilted it, another piece comes out. This flask was given for observation, but this extra piece was retained. You actually didn't observe everything. You want to make sure that you listen carefully. Perhaps you could even hear that ball rolling down there, but maybe not. I also use this with teachers as we are discussing these kinds of things to remember that although we may show students various parts of the curriculum, we'll show them how to do this or that, we'll balance equations, but I need to remember that there may be a piece in their background that they don't have yet, or that they've forgotten, or that spilled out on the way to class. They didn't pick up everything and they don't know everything. I may need to teach some math. I may need to help them understand a little piece that's missing. Don't hide it. Make sure that the students have everything that they need. And that's the Tygon tubing and the flask. It's simple enough to make. You can get these cork balls, or you can make one from a piece of cork with some sandpaper. The flask has to have a narrow neck, of course, because what happens, the ball goes inside, and then as it's tilted, the ball rolls towards the neck. And as it rolls towards the neck, it runs into the stiff tubing, or rope, as long as it's stiff, and it wedges against that tubing. And that allows it to be suspended. The secret then is to push this down. I don't know if you could hear that, but when I push it down, it releases. And then I can show the tubing, being careful to turn the flask upside down so that the cork rolls out into my hand as it's passed to the student. The flask and tube. Thank you.